Alrighty, so I have this here object file, right? And it contains a series of complex things, right? There's multiple objects in this object file, and it's a very long file. There's how many bytes are in it, right? How many lines of code are in it? About 1 million lines of code. So I have this object file, which I need to get onto a web server without it having to load a shit ton of shit. So what do? Well, I use my wfparse command, which is a new thing that I've created. A new command for it right there. We're going to tell wfparse to generate a PHP REST endpoint. We're going to use the vertex format, vertex texture normal. We're going to get the object file and material file from this location. We're going to output it into a folder called magical test. We're going to transfer the textures into magical test, and then we are going to, I forgot to put the flag here. Is it ML or LM? I don't know. I guess I'll just keep it like that, or I'll just do this. We'll run the help command. And we'll see that we want to use ML map location. Okay. For this last one. And when we run this, it's going to take a few minutes. And I'll come back once it's done. But then it finished running. As you see, I have a memory bug. We got a segment fault. But nonetheless, it's generated some things. And we can see I have the magical test folder, which I'm going to cd into. Clear this junk. And if we look at what's in this folder, right, we have a collection.json and a series of numbered folders. If we look at collection.json, we can see the name of the object file that was imported, how many objects there are, how many materials are associated, and the total number of sub-objects, right? So let's go into the first object, which starts at 0. See what's in there. We have object.json and 0.json. Let's check out object.json. We can see that we have the name of the object and the total number of sub-objects associated with it. And if we look here, we have one sub-object and we have one 0.json. So if we print out 0.json, we can see which material, which is used for texturing, which material is used, the format of the vertice data, the image data, the stride size, which is if V stands for vertex, T stands for texture, and stands for normal. Vertex has 3 values, normal has 3 values, and a texture has 2 values. So 3, 6, 7, 8. Stride of 8. This is the size of the unzipped data, 44 bytes. And here is a base 64 encoded and zlib compressed implementation of the data we saw in this file over here, right? So these vertices, you see there's 3, there's your textures down here. The vertices relative to this monument, this landing monument, have been taken from here, squished down, pre-formatted into this blob here. I need to get rid of these new lines, but I can keep them, it doesn't matter too much. So what does this do? This allows me to create a back-end system that can pick which objects to load and in what order. On top of that, I can also, because there's multiple ways to create an object, I can also like create a complex object in something like Blender. Let's see what's in Object 40. And join it all into one object. So basically, like, if I just create a cube, right? I could even show you what this creates into. If I just create a cube, it's going to create one object and one sub-object. That sub-object will contain all the cube data. Now, if I create a cube with spheres on the cube, I can do something where I merge all of the cubes into one entity, right? Like, look at this wall here, right? This wall is one object, but it's this wall post. It's one object, but it's made up of multiple smaller objects, right? We can go to this older wall version here. We could see I have these stones, I have the top, and then there's like the filler on the inside. When this gets imported, this will be imported as 3 separate objects. Whereas when this gets exported or imported, it will be one object with multiple sub-objects. And the sub-objects are defined by the different textures. Every object, every item that has a different texture is a sub-object. Post cap, post filler, and then rock A, rock B, rock C, rock D, rock B, I don't know, blah, blah, blah. So this data goes to this scene, associates these textures with these objects, and then I can export them into this file format, which is JSON encoded, which will allow me to dynamically load objects on a web browser, which will let me load 3D graphics faster and do all sorts of crazy stuff. I have to turn that on to show you, but that's that.